The antlion is not fast. It does not chase. It does not overpower. It waits. Beneath loose sand, in dry soil, along forest edges, deserts, and scrublands, there exists a predator so still that entire lives walk past it without noticing. Antlions do not announce themselves. They do not roar, sting openly, or display warning colors. They arrays. An antlion larva is one of the most specialized ambush predators in the insect world. It represents a philosophy of survival built not on speed or strength, but on inevitability. Once prey enters the zone, escape becomes a mathematical improbability. Antlions belong to the family Myrmeliantidae, part of the order Neuroptera, which also includes lacewings. Despite the name, antlions are not ants, and adult antlions do not resemble their larval form at all. This duality defines them: 2 lives, 1 purpose. The antlion exists in 2 dramatically different forms across its life cycle. The larva is the predator. The adult is the disperser. Most people only ever encounter the larva indirectly, through its signature structure, the conical sand pit. These pits appear like tiny craters, often no wider than a coin, scattered across dry sandy ground. They look accidental. They are not. Each pit is engineered. The architecture of death. An antlion larva digs backward, rotating its body in a spiral, flinging sand outward with precise flicks of its head. This creates a steep-sided cone with loose grains near the top and compacted sand beneath. The angle of the slope is critical. It is calculated to exceed the angle of repose for sand. That means once an object steps onto the slope, gravity and friction work together to ensure sliding rather than standing. At the center of this pit, buried completely except for its jaws, the antlion waits. The jaws are enormous relative to its body. They are hollow, needle-like mandibles designed not for chewing, but for puncturing and injecting digestive enzymes. When an ant, beetle, or other small arthropod slips into the pit, the sand collapses. The prey scrambles upward, triggering miniature landslides. The antlion senses vibrations instantly. If the prey almost escapes, the antlion does something remarkable. It throws sand. With rapid flicks, it launches grains of the prey, destabilizing footing, triggering further collapse. This is not random. It is directional and reactive. The antlion adjusts based on prey movement. Physics becomes a weapon. Once the prey slides to the center, the jaws snap shut. Digestive fluids are injected. The antlion does not eat solid food. It liquefies the prey internally and sucks it dry. What remains is discarded, silently. Patience as a strategy. Antlions can wait days or weeks without feeding. Their metabolism is adapted to scarcity. In arid environments, where prey is unpredictable, this patience becomes an advantage. They do not waste energy chasing. They let probability work. Every ant passing through a region becomes a potential casualty. Over time, success is guaranteed. This is not cruelty. This is optimization. Sensory world of an antlion. Antlions are nearly blind as larvae. Vision is unnecessary. Instead, they rely on mechanoreceptors, tiny sensory hairs that detect vibrations in sand. Each footstep of an ant sends ripples through the substrate. The antlion reads these signals like data. Direction, size, speed, proximity. It decides when to act. This sensory specialization allows antlions to function in total darkness. They do not need sight to dominate. Growth through consumption. Larval antlions pass through several instars, molting as they grow. Each successful capture fuels growth. Larger larvae build larger pits, allowing them to catch larger prey. Eventually, after months or even years depending on species and environment, the larva reaches maturity. Then it disappears. It cocoons itself underground and undergoes metamorphosis. What emerges is almost unrecognizable. The adult antlion. Adult antlions resemble delicate dragonflies or damselflies. They have long slender bodies, soft wings, and weak flight compared to true aerial predators. Adults do not hunt ants. Some feed minimally on nectar or small insects. Others barely feed at all. Their role is reproduction and dispersal. This split strategy is critical. The larva dominates locally. The adult spreads genetically. Colonization without competition. Evolutionarily, this division reduces pressure on a single life stage. Evolutionary success. Antlions are ancient. Fossil evidence suggests their ancestors existed over 150 million years ago. They survived mass extinctions, climate shifts, and ecosystem turnovers by sticking to a simple rule: do not compete directly. Antlions avoid arms races. They exploit physics rather than biology. Instead of developing venom, speed, or armor, they manipulate terrain. Few predators do this so effectively. Ecological role. Antlions regulate ant populations and other small arthropods. This influences seed dispersal, soil turnover, and insect competition. Their pits create microhabitats, altering sand structure and moisture. They are small-scale ecosystem engineers. Remove antlions from sandy ecosystems, and insect balance shifts. Why humans rarely notice. Antlions are quiet. They do not bite humans. They do not swarm. They do not damage crops. They exist beneath attention, and that is precisely why they are so effective. A lesson in stillness. In a world obsessed with speed, antlions represent a counter-strategy. They show that waiting, preparation, and environmental mastery can outperform aggression. They do not dominate through fear. They dominate through inevitability. Once you step into the pit, the outcome is decided before you realize danger exists. Antlions do not chase the future. They let it fall into them.